when US started IPv4, right, they had approximately 4.3 or 430 crores IPv4 addresses. They started them giving without any strategy. Believe me, there is a college, a university in America, which is Massachusetts Institute of Technology, right? Very good institute. This institute, MIT, they have given a /8 address to this university, to only this university /8 address. If you do not understand what is the meaning of /8, I'll tell you. So basically, IPv4 addresses are written as 4 octet of decimal numbers. For example, 10.0, okay, this is the private address, let's not talk about it. Let's suppose 7.0.0.0/8. Suppose this number was assigned to MIT. This is the subnet mask. This represents that starting 8 bits, or this number 7 represent the network, and remaining 3 octets or 24 bits represent your host. How many hosts can be addressed using 24 bits? It is 2 to the power 24, means it is around 16 million addresses, guys. Try to think. That is how they wasted these IP addresses, right? And that is why in 2011, there were no IP address with the highest authority. And then now the question comes, what is the highest authority? So US gave the responsibility of distributing these IPv4 addresses to IANA, which is Internet Assigned Numbers Authority, right? This is in United States. And this authority has the complete control over IP addresses. And it is the responsibility of IANA to distribute these IP addresses. But where, right? When people see that US, right, or these guys are just distributing IPv4 addresses to anybody in no sequence, in no, with nothing in their, what we can say, sorry for this. They don't have any strategy for distributing these IP addresses. They built RIR. What is the meaning of IR? These are regional internet registries, right? So previously, whole soul in charge of IP addresses was United States of America, right? By seeing all these things, they developed 5 different internet registries, which are known as regional, right? So basically, one is for Asia Pac region, which is known as APNIC, right? It is Asia Pacific Network Information Center, APNIC. Then there is another one for Africa, another one for Northern America, and then for Europe, and then I think for Australia. I'm not sure. Just have a look at the 5 internet registries are there. So INA give the big blocks to this RIR, and interestingly, in 2011, they were remaining with only 5/8 addresses, only 5, and these guys INA distributed these 5/8 addresses to all 5 regional registries, right, so that they can distribute it further. Interestingly, now INA in 2011, they didn't have any IP address at all to distribute. But does it mean that regional registries also didn't have any IP address? No, they have, right? Regional internet registries or RIRs have the responsibility to distribute these IPv6 IP addresses to ISPs, big data centers, and big enterprises. What is the meaning of ISP? If you are in India, then we have several of them, like Airtel, like Reliance Jio, and so on. Big enterprises are there like Infosys, like Wipro, and so on. Big data centers are also here. Who assigned them these addresses? In India, of course, our own local regional registry, which is APNIC. And APNIC is going to give them the IP addresses. Once they are with ISPs, ISP is going to distribute them to the customers, right? For example, I want to take an internet connection, right, from Jio or from Airtel. They are going to give me a router, and they are going to assign an IP address, the public IP address, which is routable over internet, through which I can access the internet. As simple as that, right? I am just talking about a very simple thing. It is not necessary that always ISP give you the public address. ISP can also use NAT, which is known as carrier net, but we are not talking about it. So what is the flow? The flow is simple. From IANA to regional registries, right? Sorry for that. From IANA to regional registries, from regional registries to ISPs, DCs, and big enterprises, and then eventually to the customers. As simple as that. But In 2011, INA didn't have any IP address left. So one of the biggest reason of developing this protocol, right, was because this guy, Steve Deering, thought that these numbers are not going to be enough. We need to develop a new protocol. And that's why they were developing IPv6 with in mind that this addresses should be large enough, right? And these addresses, they decided a number which is 128-bit long. 128-bit. The meaning is how many numbers you can create from 128 bits. It is 2 to the power 128. I even cannot calculate, but I can give you the rough idea. What's the meaning of it? So if you take your Earth, right, our Earth, Mother Earth, and if you put the grains, sand grains on it, take it and you fill it, the complete Earth surface. Take one grain, and from these IPv6 addresses, you can assign thousands of IPv6 addresses to single grain. Try to understand the level of what I'm talking about, right? And this in current world, network engineers couldn't even think how much big this number is. See, we are from the IPv4 world. We have a habit of saving IPv6 addresses, right? Sorry, IP addresses. But this number is phenomenal. This number is so great. 2 to the power 128. This is how scalable this protocol is, right? So I think you got the idea that why there were no IPv4 address remaining with INA in 2011, because they were distributing it without any strategy. When they got the strategy, then basically all